So we are looking at a few descriptive type questions in software engineering. Explain the bathtub curve of hardware reliability. Bathtub curve. See, this curve resembles the bathtub. That is why it is called as a bathtub curve. And this is related to hardware reliability. What it means is there are three phases in life of any hardware component. 1, 2, and 3. First is your burn in. This is the burn in, then the useful life, and then the wear out. So in this burn in phase, failure rate is quite high initially, and it starts decreasing. It is very high in the beginning, but it drops or decreases gradually as the time progresses. So it may be due to some initial testing in the premises of the organization or some more reason like this. And during useful, this is the useful time period. During this life period of useful life, failure rate is approximately constant. It is constant. Then failure rate increases in the wear out phase due to wearing out or aging of the component, because in hardware we have actual components, hardware components, and everything in this world has a life. And this is true with any hardware object. The best period is useful life. This is this graph is with respect to the time and the failure rate. And the shape of this curve is again like a bathtub, and that is why it is known as bathtub curve. And bathtub curve for hardware reliability, this is, as you see, is shown here. Next question is, consider a program for the determination of the nature of the roots of quadratic equation. So its input is a triple of positive integers a, b, c, and the values are in the interval from 0 to 100. The program output may be one of the following. It may be not a quadratic equation, it may be real roots or imaginary roots or equal roots. And you have to design the boundary value test cases and robust test cases for the program. Again, this program is to find out the nature of the roots of the quadratic equation of this form: ax square plus bx plus c. So this is your quadratic equation. Now what roots may be, you are aware of the Sridharacharya formula, and the triplet is ABC. Values are from 0 to 100, and these are the possibility of the result. So the quadratic equation, which is given by ax square plus bx plus c, the roots are real if y and when. You know Sridharacharya formula. By this we know if b square minus 4ac, if it is greater than 0, and if it is greater than 0, then we say the roots are real. If it is less than 0, then we call the roots are imaginary. If b square minus 4 is exactly equal to 0, then we say that the roots are equal. And equation is not quadratic if this x square power is not there. That is only possible when your a is 0. So a is 0. So these are the possibilities, as you can see. Now, the boundary value test cases. Let us see. The interval is from 0 to 100. 0 to 100. The first is a we take 0, b we take in between, and c we take in between. Then a we take 1, b, c. Because we want to take certain values so that our equation or the result is giving, or it is not a quadratic. This is only possible when you have this sort of combination, as we have just seen. It is not quadratic if a is equal to 0. So we are placing a equal to 0. This is a equal to 0. And b and c, because b and c are the values which are in between this 0 to 100. That is why we have taken this value. Now a equal to 1, and we know that a, b, c should be such values so that it should give the real roots. Then it is going to give the real roots. Real roots are only possible when b square minus 4ac is greater than 0. And if you place these values here, a, b, c, b square minus 4ac will be greater than 0. And these are the other options. For imaginary root, we have to take 50, 50, 50, then you have to take 99, because 0 to 100 are the values, so you have to take 99 first, 100 first, okay, 99, 100, these are the boundary values, okay. And for b also, because this is 0, so you have to take 0 and 1, these are the boundary values. In the similar fashion, for imaginary roots, you have to take 99 also, 0, 1, 99, 0, 1, 99, 100, 0, 1, 99, 100, 0, 1, 99, 100, like this, 0, 1, 99, 100. So for boundary value analysis, you have to check that all these outputs, these are the boundary value test cases. And as we know, the robust test cases are how much? They are 6n plus 1. And see, since we have three variable input, so three variable input case, the total number of test cases are 6 n plus 1, that is 6 into n, that is we have 3, 6 into 3 plus 1, how much is this? This is 19. So how many cases are there? Test cases, we have 19 test cases. So these are our 19 test cases. Okay. So these are the 19 test cases. All these, and we have to take the invalid input also, because 0 and 100 it's okay. We have taken 1 also, we have taken 99 also, but we have to take -1 also and 101 also. So 101, -1, -1, and 0 and 100 we have to take. Of course, 99 we have to take just a value before 0, after 0, because this value is invalid, this value is valid. Just before 0, 99, it is valid, and just after 100, that is 101, that is invalid. So these are the possibilities. So we are taking 19 test cases. Discuss the problems faced during software maintenance. What are the problems faced during software maintenance? Software maintenance is the maintenance of the software or change, modification, enhancement of the software after it is being deployed or being given to the apported to the consumer or the users. Now, this software maintenance are of 4 types: preventive, corrective, adaptive, and perfective, depending upon the need, depending upon the requirement. These are the 4 types. So problems which are encountered during maintenance is, the most important problem is that before correcting or modifying a program, the program needs to understand it first. You need to understand it. So the programmer must understand the impact of the intended change first of all. And what happens? Often the program is written by some other person or a group of person working over the years in isolation from each other. And often the program is changed by a person who did not understand it clearly, which may result in deterioration of the program's original organization. And the program listing, even those that are well organized, are not structured to support reading or comprehension, so you don't have documentation proper for them. So we normally read the article or book straight through, but with listing, programmer rummages back and forth. So there is a high staff turnover within the information technology industry. IT guys, sometimes they are in Oracle, sometimes they are in Infosys, sometimes they are in say any other Sapient. So they tend to, in no time, they tend to change the different companies. And because of this reason, the soft system which is maintained by the person who is not the original author, and he may not have adequate knowledge of what is being made, how it is made, why it is made, and he may introduce certain changes that may ill effect, that is, it will create a ripple effect in the program. So this problem, the problem which is there, will be worsened even more if the documentation is not there. But even if it is there, if our documentation is there, if it is an inadequate document, then also there is no worth of this document. Also, many users know that they want, but they lack the ability to express it in form of understandable to program and analyst the system. And there is always some information gap. So systems are not designed to change, it is not amenable to change, it is not welcoming the change. So if there is hardly any scope of change, maintenance will be very difficult. And therefore the approach of development should be the production of maintainable software always. Acceptance testing and beta testing. Acceptance testing, beta testing, one more testing is there which is always taught along with the acceptance testing and beta testing, that is the alpha testing. So acceptance testing and beta testing. So system test, when the system is made or built or complete, so we perform the system testing with the system as a whole, as a system. So system tests are designed to validate a fully developed system to assure that it meets the requirement. And acceptance and beta testing are the form of system testing only. Beta testing is a system testing performed by a group of friendly customers at their site. Alpha testing is a type of testing which is performed by the user at your organization. That means user will come to the developer site and he will test. Acceptance testing is the system testing which is performed by the customer to determine whether he should accept the delivery of the system or not. Define the following: structural testing, special value testing, and mutation testing. What is structural testing? Structural testing is also the white box testing or the glass box testing. So structural testing, we also call it as a white box testing. So derivation or the test cases are derived according to the program's structure. The knowledge of the program is used to identify the additional test cases. The basic objective of this type of glass box testing is to exercise all program statements if not all path combination. Not all path combination. To exercise all program statements, whether true, whether false, show the path coverage. We want to make it 100%. Now our aim is to make it 100%. So what happens here? These are the component code. This derives the test data, test is performed, and the test output is given. Special value testing. What is SVT or special value testing? So this is the form of functional testing. Special value testing is a form of functional testing, and this occurs when a tester uses his or her domain knowledge, his experience with similar program, and information about the soft spots to dense test case. And there is no guidelines that are used other than to just use the best engineering judgment which a person possesses after a long experience. So as a result, special value testing is heavily dependent on the ability, the skill, the experience of the testing person. Now, the mutation testing. What is mutation testing? In this type of testing, which is the mutation testing, the software is first tested by using an initial test suite built up from the different white box testing strategies. So first, it is tested by using the initial test suite built up from the different white box testing. Thereafter, the initial testing is complete. Mutation testing is taken up. What is the idea? The idea behind mutation testing is to make few arbitrary changes to a program at a time. Some mutation has to be done. So each time the program is changed, it is called as a mutated program, and the change affected is called as a mutant, which is the change is affected by whom? The mutant. So a mutated program is tested against the full test suite of the program, and if there exists at least one test case in the test suite for which the mutant gives an incorrect result, then the mutant is said to be dead. It is said to be dead. If there exists at least one test case in the test suite for which mutant gives incorrect result, mutant is said to be dead. And if a mutant remains alive even after the test cases has been exhausted, the test data is enhanced to kill the mutant. So a major disadvantage of mutation-based testing approach is that it is computationally very, very expensive, since you need large number of possible mutants which can be generated. What is CMM? Describe its level and compare it with ISO 9001. Capability Maturity Model. International Organization of Standardization 9001, ISO 9001 2008, ISO 9001 2015, which is the recent. What are these? CMM, Capability Maturity Model. It is a process improvement. This is process improvement, deals with process improvement. So this is a process improvement model. ISO 9001. ISO 9001 is a process compliance standard. These are process compliance standards. So the capability maturity model is a strategy for improving software process, irrespective of the actual life cycle you have used. And SEI of RAJIB University developed CMM in 1986, Software Engineering Institute. And CMM is used to judge the maturity of the software processes of the organization. And there is no certification. Please mind, there is no certification, only appraisal. And to identify the key practices that are required to increase the maturity of these processes. There are different levels of CMM. First, we have initial level. First level. So at this level, the lowest level, there are essentially no software engineering management practice. There are no software engineering management practices in place in the organization. Instead, everything is done in ad hoc basis, and things are chaotic, and approach is always reactive. In maturity level organization, level 1 organization, the software processes are often unpredictable. What about the level 2? Repeatable. At this level, the policies for managing a software project, the policies to manage a software project, and the procedure to implement these policies are established. And planning and managing new projects is based on the experience with the similar projects. So an objective in achieving the level 2 is to institutionalize effective management processes for software projects, which allow organization to repeat the successful practices and develop on other projects. So the software process capability at level 4 organization can be summarized as discipline. Right now, not at 2. Repeatable means if you have applied it to project 1, you can apply it to project 2. And the policies of managing a software project and the procedure to implement these policies are established only at the project level. Only at the project level. So whatever has been done P1, if it is successful, we apply it to P2. This is also reactive, and the policies are just there, and it will lead to a successful completion of project. So that is why maturity level 2 is okay. But now maturity level 3 says what? The standard process for developing and maintaining software across the organization is well documented, including both the software engineering and the management processes. So even the software engineering and the project management processes are well established and well documented, well organized. and the processes established at level 3, they are used to help the software managers and technical staff to perform more effectively. And the software processes capability at level 4 organization can be summarized as standard and constituent. But what it means maturity level 3 is, whereas these policies and management were limited up to the project level, in the defined level, these all characteristics are at the organization level. So all the projects P1, P2, P3, how many projects we can name, all these projects will have a proper policy that they imbibe and they follow, and there is a organizational documentation and realization, quality control, quality assurance things, and quality management systems is there well established. So level 4, at this level, the organization sets quantitative quality goals for both software products and the processes. So productivity and quality are measured for important software process activities across all the projects as part of an organization management programs. So the software process capability at level 4 organization can be summarized as predictable. That means in the level 4 of CMM, the processes are quantitatively and statistically tried to not to improve, but they are measured and they are controlled properly in the managed level. All the processes, all the key processes area are well controlled and managed through statistical and quantitative measures. In the optimized level, at this level, the entire organization is focused on continuous process improvement because they have already achieved. See, at every level, the previous level is already achieved. So at this level, the entire organization is focused on continuous process improvement. And the organization have the means to identify the, say, SWOT analysis, strength, weaknesses, and these operations and threats, etc. So they identify weaknesses and strengthen the process proactively, not reactively as there was in 1, 2, and 3, third level. So they strengthen the process proactively, and the goal of preventing the occurrence of defect. So the software process capability at level 4 organization can be summarized as continuously improving, not level 4, but it is level 5. ISO 9001 and CMM. What is ISO 9001 and CMM? ISO 9001 requires, we are talking about the management responsibility, the document control, the purchasing, the training, the internal quality audit. Okay, all this has to be there. And let me tell you, it has changed a bit now. 9001 2015, some terminology has changed. In 9001 2015, now we don't call them as product, but we call them as product and services. Now there is no preventive action, but there is risk-based RBT, risk-based thinking, and the one organization context is being used, and various documentation which were given in ISO 9001 2008. Now they are being the heading has been changed. Now we only have a one-word documentation under which various documentation can be written. It is left to the organization to make the document. And more importantly is the management responsibility has been increased or elevated. Now for everything the management responsibility is there, their commitment and their accountability has also been ascertained. So in ISO 9001, this is a process compliance standard. First, management responsibility, that is ISO 9001 requires that the quality policy has to be defined, documented, understood, implemented, maintained. Whereas in CMM, management responsibility for quality policy and verification activities is primarily addressed in the software quality assurance. So in CMM, it is done by SQA. In 9001, it requires this is to be defined, documented, understood, implemented, and maintained. So this is your management responsibility, and here the management responsibility for quality is with the SQA. Document control, ISO 9001 requires that the distribution and modification of document has to be controlled. And in CMM, the configuration management practices characterizing the document control, they are describing software configuration management. So SCM says, CMM says document control should be done in SCM. In 9001, it is said that all the documentation, the modification and everything has to be controlled properly. In purchasing, ISO 9001 requires that the purchased product conform to their specified requirement. In CMM, this is addressed in the software subcontract management. Training. ISO 9001 requires that training needs to be identified and that training is to be provided, records of training are to be maintained. While in CMM, the specified trainings are identified in the training and the orientation practices in the ability to perform common feature. This is the specified training it needs to be identified and they needs to be trained. People needs to be trained. Internal quality audit. ISO 9001 requires that the audit be planned and performed. The results of the audits are communicated to the management and any deficiency found are to be corrected. While there are specific audits in the CMM, they are called out in auditing practices and the verifying implementation common feature. In CMM, there is if you are doing the audit, it is well and good. So they are always comprehend the this quality audit. While CMM is again in this CMM, they doesn't specifically talk about this auditing, but they are good with if, because they are saying that if the management is dedicated to the controlling, to the monitoring processes, then the audit has to be there. Then comes the spiral product or spiral model here. So spiral model is a realistic approach to the development of large-scale systems and software. Just justify and explain the model. So there are various advantages of your spiral model that makes it a realistic approach to development of large-scale systems and software. First is the spiral model. The spiral model, see, it is you can assume it to be prototype plus waterfall. Okay, this is a spiral model with a touch of, or with the say an amalgamation or the coverage of risk-based analysis. So the spiral model promotes quality assurance through prototyping at each stage in the system development. The spiral model is a realistic approach to the development of large-scale software products because the software evolves as the process progresses, because you make the prototypes. And the developer and the client, they better understand and react to the risk at each evolutionary level. And the model uses prototyping as a risk reduction mechanism, and it allows for the development of prototypes at any stage of the evolutionary development. Then it maintains a systematic stepwise approach like the classical life cycle model, like waterfall, but incorporates in it an iterative framework also that is more reflective to the real world. So if employed correctly, this model should reduce the risk before they become problematic, as consideration of the technical risk as considered at all stages. And this model is also known as the spiral lifecycle model, is a system development lifecycle model used in IT and software development. So this model of development combines the feature of prototyping model and waterfall model, and the spiral model is used for large, expensive and complicated projects. And more important is the 4 quadrant. Here you do risk analysis or even you analyze, then you mitigate, control, and then you plan for this next phase. So every time you are performing the risk analysis, so rather than getting errors or problems or modification at the design or later phases, it is better to deal them at the initial phases. This was presented by Barry Boehm in 1986, incorporated the project risk factor, and this is designed in order to overcome the disadvantage of waterfall model. So the radial dimension represents the cumulative cost incurred in accomplishing the steps done so far, and the angular means this one. See, this is, so the radial distance is what? This radial distance, or radial dimension. This radial dimension represents the cumulative cost incurred in accomplishing the steps done so far, and the angular dimension represents the progress made in completing each cycle of the spiral. This is the cost, this is the progress, and each loop is a development stage. And it balances all the risks element, that is the high risk element, this must be lowered, and the people concerned with the project complete each phase with review. There are different phases of spiral model. As I said, we have planning here, you have risk analysis here, and then you have development and assessment. So now you have development and assessment. So planning, risk analysis, development and assessment. So in this phase, the objectives, alternatives and constraints of the projects are determined and documented. So the objectives and the other specifications are fixed in order to decide which of strategies or approaches are to be followed during the project lifecycle. In the risk analysis, the second quadrant, all possible and available alternatives which can help in developing a cost-effective project, they are analyzed and strategies are decided to use them. And this phase has been added specially in order to identify and resolve all the possible risk in the project development. Then comes the third quadrant here, development. So in this phase, the actual development of the project is carried out. The output of this phase is passed through all the phase iteratively in order to obtain the improvement in the same phase. And then assessment. In this phase, the development product is passed on to the customer in order to receive customer comments and suggestions which can help in identifying and resolving potential errors in the software development. So these are a few questions. See more questions on your software engineering descriptive. Thank you so much. Take care.